The universe is vast. Its scale often defies human comprehension. Yet, we persist in our quest to understand our place within it. Today, on May 30th, 2025, we mark a monumental step in that journey. Astronomers have announced the discovery of a new exoplanet. This isn't just any exoplanet. It's a world named Proxima Centauri d'. It orbits our nearest stellar neighbor, and it shows tantalizing signs of potential habitability. The excitement in the scientific community is palpable. It ripples outwards, touching everyone who has ever looked up at the night sky and wondered. This is a big deal. This remarkable discovery was made possible by the Aurora space telescope. Aurora is a marvel of modern engineering. It represents humanity's insatiable curiosity. Launched just a few years ago, its primary mission is to find Earth-like planets. It specifically targets stars close to our own solar system. Aurora uses cutting-edge optics and highly sensitive detectors. These allow it to spot the incredibly subtle dimming of starlight. This dimming occurs when a planet passes in front of its star. This is known as the transit method. Aurora has already identified several exoplanets, but Proxima Centauri d' is its crown jewel so far. The feeling of discovery in science is unique. It is a blend of meticulous work and sudden revelation. Imagine sifting through mountains of data from Aurora. Light curves, spectral analyses, orbital calculations. For years, astronomers have dreamed of finding a truly habitable world nearby. The cosmos is under no obligation to provide one. Yet, the laws of physics, chemistry, and biology might be universal. Finding even one candidate planet like d' fuels that hope. It transforms the abstract search for life into something tangible, something we can point to, something we can study. The team behind the Aurora telescope worked tirelessly. They are based at observatories and universities around the globe. They meticulously analyzed the faint signals from the Proxima Centauri system. Early hints of d''s existence were met with cautious optimism. More observations were needed for confirmation. The data had to be checked and rechecked. Then, the moment came. The evidence was undeniable. A new world had been unveiled. The announcement sent shockwaves through astronomy. It reminds us that the universe still holds profound surprises. We just need to keep looking. So, what do we know about Proxima Centauri d'? It is an exoplanet. This means it orbits a star outside our solar system. Its estimated size is about 1.3 times that of Earth. Its mass is thought to be slightly greater, perhaps 1.5 times Earth's mass. This suggests it is likely a rocky planet like our own, not a gas giant like Jupiter or Saturn. It orbits Proxima Centauri. This is the closest star to our Sun. It is located a mere 4.24 light-years away. That's practically next door in cosmic terms. This proximity makes d' an incredibly exciting target for future study. Proxima Centauri itself is an M-dwarf star. M-dwarfs are much smaller and cooler than our Sun. They are also much dimmer. They burn their fuel incredibly slowly. This means they have lifespans far exceeding that of stars like our Sun. Trillions of years, potentially. This long lifespan could offer an enormous window for life to emerge and evolve on any orbiting planets. However, M-dwarfs also present challenges for habitability. They are known for powerful stellar flares. These flares could strip away a planet's atmosphere if it's not protected. We need to understand this environment. Crucially, Proxima Centauri d' orbits within its star's habitable zone. This is often called the Goldilocks zone. Not too hot, not too cold, but just right. In this region, the temperature on a planet's surface could allow liquid water to exist. Liquid water is essential for life as we know it. Without it, the complex chemistry that underpins biology struggles to get started. The discovery that d' lies comfortably within this zone is a major piece of the puzzle. It significantly boosts its potential for habitability. This is what we look for. Life around an M-dwarf like Proxima Centauri faces other hurdles. Planets in the habitable zone of M-dwarfs are often tidally locked. This means one side of the planet permanently faces the star. The other side is locked in perpetual darkness. This could lead to extreme temperature differences. However, a sufficiently thick atmosphere could redistribute heat. It could make the planet more uniformly temperate. The presence of a substantial atmosphere on d', as suggested by initial data, is therefore very encouraging. It might act as both a shield and a climate regulator. The most electrifying aspect of the Proxima Centauri d' discovery is its atmosphere. The Aurora telescope didn't just find the planet, it also gave us our first glimpse of the gases surrounding it. Preliminary analysis has detected the presence of oxygen. Oxygen is a highly reactive gas. On Earth, it is overwhelmingly produced by life. Photosynthesis, carried out by plants and some microbes, releases oxygen into our atmosphere. Finding it on an exoplanet is a profound indicator. It makes us lean in. It makes us ask more questions. This could be a game changer. Alongside oxygen, Aurora's instruments also detected methane. Methane is another gas that can be a biosignature. On Earth, a significant portion of atmospheric methane is produced by living organisms. Think of microbes in wetlands or the digestive systems of animals. While methane can also be produced by geological processes, its presence alongside oxygen is particularly intriguing. Certain combinations of gases are more suggestive of life than others. Oxygen and methane together in significant quantities are a potent duo. They don't typically coexist in large amounts without a constant source. Life is a very good candidate for that source. How did Aurora achieve this? It used a technique called transit spectroscopy. When Proxima Centauri D' passes in front of its star, some of the starlight filters through the planet's atmosphere. Different gases in the atmosphere absorb specific wavelengths or colors of light. Aurora's sensitive spectrographs can analyze this filtered starlight. They can identify the chemical fingerprints of the gases present. It's like a cosmic barcode. The specific dips in the light spectrum reveal the telltale signatures of both oxygen and methane. This is a triumph of technology and scientific ingenuity. However, we must remain scientifically rigorous. The presence of oxygen and methane is not definitive proof of life. There are known abiotic or non-biological processes that can produce these gases. For example, intense ultraviolet radiation from the star could split water molecules into oxygen and hydrogen. Geological activity could release methane from the planet's interior. But the combination of both, in the amounts suggested, makes these abiotic explanations less straightforward. The scientific community will now work hard to rule out these non-life scenarios. The evidence is compelling, but not yet conclusive. The discovery of Proxima Centauri D', with its intriguing atmosphere, is just the beginning. It's a call to action for astronomers worldwide. The immediate next step is intensive follow-up observations. Scientists will be clamoring for time on other powerful telescopes. Both ground-based and space-based instruments will be pointed towards Proxima Centauri. We need to confirm the atmospheric composition detected by Aurora. We need to measure the concentrations of oxygen and methane more precisely. We need to search for other gases like water vapor or ozone. Each new piece of data will help build a clearer picture of this alien world. The ultimate goal is to determine if these gases are indeed biosignatures. This means looking for patterns and ratios that are difficult to explain without life. Scientists will model different atmospheric scenarios. They will consider all known geological and photochemical processes. The James Webb Space Telescope, with its unparalleled infrared capabilities, will be crucial. It can probe exoplanet atmospheres in greater detail than ever before. Proving extraterrestrial life exists is an extraordinary claim. It requires extraordinary evidence. This careful, methodical process is at the heart of science. We must be patient, yet persistent. This discovery of Proxima Centauri D' has a profound impact on the broader search for extraterrestrial life. It reinforces the idea that potentially habitable planets might be common, especially around M-dwarf stars, which are the most numerous type of star in our galaxy. If a world with oxygen and methane can exist around our very nearest stellar neighbor, imagine the possibilities among the billions of other stars in the Milky Way. It fuels our optimism. It provides a powerful incentive to continue developing new technologies, new telescopes, new methods for detecting and characterizing distant worlds. The journey to understand our place in the cosmos is a long one. We are taking significant steps. Proxima Centauri D' is a beacon of hope. It suggests we are getting closer to answering one of humanity's oldest questions. Are we alone? Future missions will undoubtedly unveil even more exoplanets. Some may be even more Earth-like. Some may hold even clearer signs of life. The universe is slowly revealing its secrets, and we, with our relentless curiosity and our ever-improving tools, are ready to listen. The search continues. The cosmos awaits.